For those who don't know, Harbor Research, we are a research and strategy consulting firm. We've been around since the 80s and completely focused on developing new growth strategies for our clients around emerging technologies, including things like artificial intelligence, IoT, new sensing and networking technologies, and so on. We've been engaged with ASHB and formerly CABA for quite a while, supporting some of these landmark research projects, and are currently engaged in a number of areas as well. But a long history in buildings and these emerging technologies, and trying to put the two together and look at the opportunities at the intersections of both. So I will start just with a quick introduction to AI. I know there's been a lot said about out in the marketplace, and there's been a lot of hype, particularly around ChatGPT and related generative AI technologies, but AI has been been around for a while, so I'll start there. We'll look at some examples of use cases in intelligent buildings, and how to think about value creation in intelligent buildings with regards to AI, and then try and shift to an open discussion from there. So when we think about the evolution of AI, we go all the way back to the really the late 40s and early 50s with Alan Turing and the Turing test, and all the cybernetics that came out of the Second World War, kind of set the stage for a lot of the more modern developments in terms of data analytics, early neural networks, and classification systems. Second evolution of AI was really the late 90s into the really mid 2000s, when there was a much greater focus on business intelligence and analyzing data coming from the computerization of a lot of systems to be able to understand how businesses could perform better. But while there was some early design of convolutional and recurrent neural networks, which are different types of AI, and we'll look at a little bit more of that on the next page. There was still not a significant amount of application of AI in that time frame, just because of the cost associated with the computing and actual analysis of that data and the development of those models. So as the cost of computing and data storage and whatnot has come down significantly over the last decade and a half, that's where we've seen this kind of now really significant uptake of artificial intelligence and development of these massive models to help predict certain outcomes and so on. So that's where we're at today, kind of this third evolution. So classification and regression are probably the most simplest forms of AI that evolved into this convolutional neural networks, or kind of the analysis of more visual imagery, and then recurrent neural networks, and then deep reinforcement learning, and generative AI, which is really it's somewhat unlike the other categories on this chart. It's kind of a combination of deep reinforcement learning and those transformer models that everybody's hearing so much about, but the ability to take so many different variables, combine them into a single model that is able to predict and actually generate responses based on text or other types of inputs. So a lot of different types of AI, all are actually in use today in some way, shape, and form in different intelligent buildings use cases. And so I think we'll talk about a few of them, but important to know that even kind of some of the more simple classification and regression forms of artificial intelligence can still be applied and have pretty significant impact today. The last more definitional slide, we look at kind of data analytics and artificial intelligence as subsets of this broader data science landscape. And it's obviously a little bit hard to follow a lot of these terms. Of course, when you hear things like machine learning and deep learning, those are completely and utterly artificial intelligence related. Whereas certain types of analytics can be done very manually. So even predictive and prescriptive analytics can be done somewhat manually to a certain extent. And so if something is predictive analytics, unless it's kind of automated in that way, it could still be considered data analytics and not really artificial intelligence. But of course, there's just a pretty significant overlap there. And so part of the difficulty is trying to figure out in the marketplace who's really doing things with AI versus who's more just trying to capitalize on the hype and marketing. But important to understand the overlap of a lot of these categories and where they fit together. All right, so as we get into intelligent buildings, there's a significant number of trends and forces driving the market for AI in intelligent buildings. From a technology trend standpoint, I commented on on a few of these previously. Kind of overall, just the the ability to compute and store data in the cloud, reducing overall costs is a pretty significant driver, as well as the ability to access data through sensors and systems where data wasn't previously able to be collected or was more manually collected and charted over time. And so that combined with all of the available tools that are out in the marketplace that are starting to enable even non-data scientists to work with and analyze and understand this data is all kind of driving new ways of applying it, and the ability for even non-technology companies to apply it in a way that's valuable for them. On the customer side of things, there's a number of objectives in the across a number of commercial buildings that are driving building managers, owners, operators to really invest in new technologies. So whether it be resiliency of building systems, whether it be the ability to increase occupant satisfaction, the need to achieve certain sustainability goals, whatever it might be, these needs are opening up new opportunities and new desires for customers to experiment with these kinds of technologies, including artificial intelligence and machine learning. And so with that kind of more willingness to explore these technologies, the opportunity becomes even more great. So on the supply side, obviously there's so many of these AI and ML tools out there, but also a lot of suppliers are experimenting with different ways to apply these tools to help solve those outcomes for customers. And I think this is moving beyond just applying data analytics and artificial intelligence in a way that improves the operations of companies, but applying them in a way that actually improves the value that's delivered to customers in achieving those goals that they might have. And so it's all about how these technologies get applied to kind of solve those customer problems or address those customer needs. And that's where the value lies. So we'll talk a little bit more about what those could be here in the coming slides. Many different use cases for AI. Of course, AI is a very horizontal technology category, I guess I would call it. It can be applied in many different ways, many different types of AI is what we've been looking at. But whether it's applied in certain areas like asset management and uptime, so things like predictive maintenance can be informed by artificial intelligence, or prescriptive maintenance, as well as opportunities to optimize certain subsystems in buildings. AI can be applied to help with that. It can also be applied in user safety and security modes. So whether it be certain surveillance technologies to identify potential threats or keep a building secure, or whether it be even things like just managing the use of certain rooms or areas within a building based on occupancy and based on people's needs, can be applied in many different ways. And so some of our research kind of tried to look into where these artificial intelligence technologies and capabilities were being applied. the most in the near term. And those 6 highlighted boxes in the middle of the screen there is where we've seen some significant investment and development of technologies at this point. It's not necessarily to say that there isn't innovation or development going on elsewhere, but it's one of those, this is just where we're seeing most of the development at this point. All of this is saying is that from an AI and particularly AI and intelligent buildings, there's many different applications of AI as it relates to business. So, whether it be like sales and customer engagement, whether it be, like I was describing earlier, ways to improve internal operations. What we're really talking about when we think about intelligent buildings is the ways to take data from sensors and systems within the building itself, combine and analyze that data and do so to drive a specific set of outcomes. And that's where these kinds of application categories come in. And so it's by no means meant to be this is the full landscape of AI by any means. It's really just meant to try and understand or gauge kind of the scope of how these can be applied in an intelligent buildings context. And then finally, so we do believe that these AI technologies will evolve over time, and some of this more basic supervised artificial intelligence, kind of these classifications and regression models, like I said, are still very valuable. So whether it be supporting kind of automation or control in certain instances, fault detection, that kind of thing, more basic predictive maintenance, there's still and there's a significant amount of value available for these kinds of more basic supervised artificial intelligence solutions. But as you start to expand to include more neural network types of AI and even generative AI, you start to expand the scope of what can be done and the value that can be created. A lot via the integration of some of these systems. So things like the full energy grid and the optimization of how it works and interacts with a single building or multiple buildings across a campus or even across a city. Full on occupant behavior analysis, air quality monitoring and related actions based on that. So there's a lot that can be done as the capabilities of AI and the technical maturity of AI as it's applied increases. But this isn't to say that you need to have generative AI, or you need to offer generative AI to get any value out of it or to provide any value to customers. Rather, it's really gets back to what is the ultimate goal that you're trying to achieve for a customer, the problem you're trying to solve for that customer, and how to apply AI in certain instances to help achieve that goal. Sorry, there's a fire truck going by. So some of the use cases that we had identified with that are through our research, really just this is both kind of a combination of maybe what's out there today versus other sorts of academic articles and just analysis of what could potentially be done with AI. So these are really just meant to be examples more for discussion and to be thought-provoking than they are kind of the full scope of what can or should be done with AI. But so what we've done is try to organize maybe more basic and basic supervised AI technologies against more simple applications or more very specific applications like HVAC optimization or water leak detection or energy monitoring and savings recommendations. All of that can be done in a relatively simple manner. A lot of that is done today, not necessarily with AI, but with other sorts of data analytics and applying expertise to certain problems that people have. But as you move up into the right on this chart, you start to see both the integration of data from various systems within a building, as well as an expanding, and a more advanced set of AI capabilities, maybe even in some cases, the combination of certain AI capabilities, and then also resulting in kind of a combination of these use cases to drive value in many different ways. And so in that middle, in the middle box on the screen, kind of the preference-based environment control and HVAC optimization, it's an example of when, if you understand what certain occupant preferences are with regards to temperature, humidity, and so on, but at the same time you have, let's say you have certain energy usage requirements or cost targets or whatever, you can balance and optimize against those different targets to both hopefully improve overall satisfaction for occupants within the building while not maybe overdoing the HVAC system or paying too much from an energy standpoint, because there's just many different very specific needs of these occupants. So it's about the ability to balance and tweak these goals based on what you're after. And of course, the beauty of these systems is that they learn over time to better achieve the goals that you set for them. So eventually all of this gets to a much more automated, integrated building system, and that includes digital twins and includes optimization capabilities. And there's many AI models working together to help inform more autonomous and optimized building and the more autonomous built environments, and ultimately allows us to achieve the full potential and value of these intelligent buildings in these areas. We've highlighted a few examples of AI applications and outcomes in buildings. There's just so many out there, and of course, as I said, it's a little bit difficult to pick through the all of the marketing and hype around these things. So whether or not some of these are truly informed by AI or whether it's really just more basic data analytics, again, it's a little bit hard to tell. But good to be understanding kind of where we're seeing AI be at least elevated as a solution area for certain things. Of course, predictive maintenance and optimization, we believe, is a big category. The ability for OEMs and service providers to better help building managers, owners, and operators maintain and get the most out of their assets, even drive some sort of optimization of those systems as they're working. Energy management continues to be a big area since it's such a big cost center for certain types of buildings, and companies are trying to target more sustainability goals. And then occupant safety and security, particularly around occupancy, more like I guess occupant satisfaction, safety and security, really. But certain security applications of this, as I had said before, whether it be detecting bad actors or intruders, or even more broader occupant satisfaction things like the ability to control different very specific zones for temperature and humidity, and just optimize that based on what occupants are looking for. Are all these kinds of applications of AI that are currently out there today, and there's many more. This is just a cross section of what we found in our research. And the last slide I'll get into before I can open it up for some question and discussion. So a lot of what we work with our clients on is really, trying to get beyond this idea of artificial intelligence and the hype around how these technologies can completely change the way that companies do business and the way that they serve customers and the value that they provide to customers, and come back to some core questions about creating value propositions and really understanding why you should be applying AI in certain instances, and if AI in certain cases really is the proper technology scope to be looking at, or whether you're just getting a bit swept up in the hype and not really thinking through all of this. So we like to separate this discussion into two sides. One is creating value. So what, really, what are you trying to do for a customer that creates value for them, that they'll find valuable, that they'll pay you for? And then the other side is actually capturing that value. And that relates to kind of the business model around serving up that solution that's described on the top half of the slide in a way that can eventually be monetized. And so really starting with questions like, what is the desired customer experience? What do they actually need? What outcomes are they trying to achieve? And how do they think about value? What actually is valuable for those customers can help a company define what solution or how they should be approaching this. And if AI can be properly applied in this situation. And then again, what business model should be set up to capture that can be a second set of questions around all of that. So AI for AI's sake, it's funny, there's a lot of, we've seen some data come out recently that, especially on the consumer side, customers are pretty wary of AI, partly because of the, I guess, probably lack of understanding of how it works, but also the trepidation around data sharing and privacy. And so it's interesting. It'll be interesting to see what that looks like from an intelligent buildings perspective. We've done some work on that with ASHB, but AI for AI's sake isn't going to work in the long run here. So really trying to understand, define, and develop solutions that are value based for customers that leverage AI, I think is the most important thing to be thinking about in the near term, to not get swept up in that hype and eventually gain significant value from that for a company. So I can take questions. We can open it up for discussion. I'm not sure how these meetings usually go. I see that there's some things in the chat, but I'm not sure if those are questions. Yeah.
So thank you, Harry. I appreciate the presentation. Certainly very insightful. And definitely open up to some questions here, folks. We can do a couple of different things with questions. You can type it into the Q&A box, and we can go about it that way. Or if there's a pause in the chatter and you want to unmute and just ask Harry the question, that's fine. And Harry, I'll kind of kick things off.
Sure.
Here at NAVCO, we looked at AI for some different solutions. They weren't necessarily building automation or intelligence solutions, but one of the things that we did struggle with was how AI learns. Would it be learning just from the information, in this case, within our building, or is it taking knowledge that it acquired at other buildings or maybe a portfolio of buildings to best make those decisions? Can you talk a little to that?
So are you speaking from like a customer's perspective, I guess, or are you
the individual building, how is AI determining the best course of action or the most optimum plan for that building?
Okay. I guess I would say from a customer's perspective, and I could take this in a few different directions, I guess, but from a customer's perspective, it all gets back to the way that they prioritize their certain objectives and goals as it relates to their whole operation. So I think we've defined in the past maybe 5 or 6 different objectives or outcomes that building customers are trying to strive for, and those could be quite could be different priority or prioritized differently based on the type of building or even the customer itself. But these are things, as I was saying before, like resiliency of systems. This could be sustainability or compliance or occupant satisfaction, things like that. And so kind of depending on how a building is trying to prioritize those outcomes, and those could be different year to year, those could be different quarter to quarter, that can help inform how they approach the market for looking at certain solutions, and then how suppliers then should approach those companies and customers accounts for supplying those kinds of solutions. So if it is something like resiliency, and there's priorities on that, and they're willing to invest in solutions that make their operations more resilient, whether that be to something like a natural disaster, or whether that be to increasing heat in the summer requiring a more significant a load on HVAC systems, whatever that might be, you can craft solutions around those kinds of target goals and objectives to better serve what those customers are after. And again, I think ultimately, in my mind, it's less about the fact that AI can help, although sure, sometimes good to communicate how AI can do it better than maybe some more manual solutions or service-driven solutions or whatever that is. But it's much more getting back to what's the value that customer is trying to get out of these systems, and how can these solutions be applied to help achieve that.
Mhm.
Yeah, it's a very similar. I guess I would see it as a very similar customer journey to any other sort of technology-based solution. It's just from an AI standpoint, important to kind of explain, in how artificial intelligence can improve the way that these values are achieved for customers, even if some of the underlying technology might be a bit complex to understand, or isn't completely visible to a customer who's using it.
Thank you. Appreciate that. Anyone else with any questions?
Yeah, this is Ken Wax. Got an observation and question. I noticed at the Consumer Electronics Show in January that most companies with any sort of algorithm built into the system was now claiming it was artificial intelligence.
Yeah.
My understanding is AI really needs to be based on learning and adapting rather than just taking in a bunch of sensor data, running an algorithm on it, and running an actuator as a result. For this reason, and I'll just bundle these two issues together, I chair the world standards body for ISO and IEC in energy management. And after about 2 or 3 years of effort, we published our first AI standard for energy management. And we specifically said this is very narrowly tailored AI, where the system learns how an occupant uses a home or building and determines where to draw the power from local sources or from the grid, how to allocate power to the user's desired major loads, and how to do this within the budgetary constraints or concerns about climate impact of the occupant. The whole idea is the occupant chooses their preferences, sets their budget, expresses any concerns they may or may not have about environmental impact. And the artificial intelligence aspects comes up with a solution unique to that building. So my fundamental question is, how much is learning and adapting fundamental to AI?
Yeah, I mean that's a great question. I mean, if I just go back, so learning and adapting really comes in this kind of once we get into these neural networks and deep reinforcement learning. So classification and regression, there's some learning involved in all of that, and a lot of training involved, particularly in things like classification models. But they're relatively static in nature and are very targeted at very specific outcomes. Therefore making it very difficult to plug in a bunch of different parameters or preferences and have it automatically adjust a system based on those to an optimal set of goals or outcomes. And so that's really where we start to see a lot of the greater value is in those kinds of neural networks and deep reinforcement learning, where things are actually learning from the models, and the AI is actually learning from the experience and improving the outcome over time, as opposed to just saying, hey, we've seen this pattern of data before, we expect it to look like X. That done automatically is artificial intelligence, is based on algorithms and can be considered more simple and more basic supervised artificial intelligence, but it is that more advanced unsupervised intelligence that happens in these neural networks and deep reinforcement learning that a lot of the true value can be achieved.
So you're saying learning is a step above pattern recognition.
Yeah. I mean, at the most basic, so like I think we've, I'm sure many folks have seen these kinds of examples where, artificial intelligence is recognizing pictures of cats, and if you put a dog in there, it might think that that's a cat, but over time it will realize that it's not a cat if it's told that, hey, that's not a cat, that's a different animal, even though it looks similar. It's got four legs, it's got a tail, whatever, right? So it can learn that, and it can, and it's kind of a very basic kind of learning, because it's very targeted at something like, I'm just trying to identify cats out of all of these other pictures, right? So you can apply that stuff in a building space. Like I think the example we have here on the bottom left in this classification is like recognizing the type of HVAC fault that occurred in a piece of equipment. So I can see, if I'm looking at these different data points, and these data points are coming in, and I know that a certain data point means an electrical fault, associated with a certain aspect of the system, then I can recognize that, and I can elevate that as an AI to whoever wants to see it, and categorize that, classify that as that kind of issue. That requires some learning, but we would typically call that supervised learning. It takes somebody in the loop to help try and develop that understanding on the part of AI, to tune that algorithm, to help train that algorithm to be able to identify that, which is a lot different than the unsupervised learning that occurs in a lot of these neural networks and deep reinforcement learning. That is, the AI is itself learning over time based on some feedback, but also based on all of this other data coming in, and the sets of objectives and outcomes that companies want to achieve based on that. So it's kind of it really is a progression. And that unsupervised learning that happens up here is much more valuable and automatable, I guess, than the more supervised learning that requires humans to help train over time.
Awesome. Thanks, Harry.
Yep.
Got time for maybe one more question if anyone has one.
Oh, it looks like we've got one in the Q&A.
Perfect.
What are the challenges that you face in introducing AI for built environment? New building can have allocations for installations, but existing buildings challenging maintenance requirements of AI system. So I'd say one of the most significant challenges, I think, that we've seen is really at the most basic level. Before you can even get to the point where you can say, hey, we can implement AI, you need to have the data to feed into an AI system to be able to affect certain outcomes that you want to achieve. So if I'm not really collecting data from my assets, let's say, in a way that allows me to feed that in, or I'm not collecting the right data, I may need to invest in a number of sensors and even potentially some software before I even get to an AI solution. And so we've seen some difficulties there in the way that data is organized, or that data isn't even collected today, that can be a barrier to implementing some of these AI solutions in buildings. But another challenge is kind of communicating, as I was referring to earlier, communicating what the AI is doing and making somebody feel comfortable with the use of that AI. So having that proper level of human in the loop, and the ability to manually control things, not just rely on automated control, and that might require some different or have some different requirements on the system itself. And then I think third is always going to come back to our ROI, and aligning that ROI with those outcome priorities that I was describing earlier. So, of course, AI, around something like energy management can be great in helping saving energy and still improving occupant satisfaction. But if a company's not super concerned about saving energy at this point, or maybe they've already invested significantly in energy management systems, trying to communicate and understand the value of investing in a newer technology may be more difficult versus a company who's really focused on trying to save those energy or save on energy costs or optimize the use of that energy over time. Be a lot easier to communicate that ROI and values. I think those are three key challenges that we've seen come up.
Great. Well, thank you very much, Harry. Appreciate you stepping up here. A lot of great information. I mean, the path forward is going to be very, very interesting with a lot of great benefits, I think.